Good morning to all. Today I'm going to explain the topic shielding. Shielding is a technique or methodology to reduce or prevent the coupling of unwanted or undesired electromagnetic energy. The source or the emitter or the culprit emits some sort of undesired energy. This undesired energy can be picked by the receptor, and this can affect the functioning of the receptor. In order to enable the normal operation of the receptor, we are in need to avoid this unwanted coupling. For that, we use a material for shielding. Whether the shielding is effective or same for all range of the electromagnetic spectrum means it is not at all. It is different for different range of frequencies. Next question arises whether this shielding prevents the unwanted energy in 100%. This is not at all possible because there are some discontinuities or holes or windows in the shielding. So because of the presence of these discontinuities or holes, you don't get the prevention of undesired electromagnetic energy in as in the ideal case. How it is implemented means it is implemented by employing a metallic barrier in between the emitter and receptor. This there is a source or emitter or a culprit as well as a receptor. So in between them the electromagnetic wave propagates. So this electromagnetic waves experience some sort of impedance that is called the intrinsic impedance because the propagation medium is air or it can be different. So what is the impedance experienced by this wave means it is equal to root of omega mu naught by 2 sigma into 1 minus j. So whether this intrinsic impedance value is same for all materials and in all region means it is different depending upon the materials as well as depending upon the spectrum it varies. In here we have considered the conductors. It is low. The intrinsic impedance value is low for conductors, that too in the optical region. Next component is what are the mechanism needed for shielding. There are two losses occurring. One is reflection loss and absorption loss. How this reflection loss is occurring means the electromagnetic energy propagating will be impinging the shielding material and it experiences some partial loss. Why means due to the impedance mismatch. The signal is experiencing a different impedance as it reaches the shielding. Another one is absorption loss. The shielding material itself is absorbing some amount of EF signal. So the remaining alone propagates to the receptor. This is called absorption loss. So there is a term shielding effectiveness. Its unit is dB. It depends upon the attenuation due to reflection, absorption, and attenuation in the infrared region. Now, this is a diagram for the shielding mechanism for plane waves. We have considered a plane wave is being incident on a metallic barrier, that is a shielding. So, this incident wave is having E as well as H component as it is an electromagnetic wave, and the orientation of the E as well as H component, it is continuously changing as it propagates. So when it reaches the metallic barrier, some amount of energy is reflected. That is also shown in the diagram. Inside the barrier also, on reaching certain area of the barrier, it experiences some sort of internal reflection, and the thickness of the material barrier is T we have considered here. After the shielding, the EM signal coming out of the shielding is an attenuated one because it has been subjected to reflection as well as absorption. So the remaining signal alone reaches the receptor. Next is shielding theory. Whether this practical shielding and ideal shielding performance is same means it is not at all the same. It is different. So what are the factors that affect the practical shielding performance means it is dependent on frequency, distance between the source as well as the shielding walls, and polarization of the field. Polarization means orientation of the E as well as H component. We know that electric and magnetic components has longitudinal and transverse component. So impedance depends upon the transverse component of the E and H component. Next is what about the impedance value? Whether it is large or whether it is small. Z value depends upon E. If E is dominating and E value is larger then H component means impedance is large. Suppose E value is not dominating, it implies magnetic field is dominating means Z is small. Wave impedance depends on the distance. If the distance is very large, that is greater than d square by 2 lambda naught means it is equal to root of j omega mu by sigma plus j omega epsilon. D is the size of the source because we have two regions, near field region and far field region. So in the far field region, Z omega is no ZW, the wave impedance is equal to root of j omega mu by sigma plus j omega epsilon. In the near field region, when r is very small when compared to lambda naught by 2 pi means the impedance for E component or the electric field component is equal to lambda naught eta naught by 2 pi r, and for H component the impedance is equal to eta naught 2 pi r by lambda naught. Then how can we define the shielding effectiveness? It is defined as the ratio of powers at the receptor without and with barrier. For plane waves, shielding effectiveness is equal to 10 log to the base 10 P1 by P2. What does this 1 and 2 suffixes represent? It represents 1 represents without shielding and 2 represents there is a shielding at the receptor. Shielding effectiveness of electric field component is equal to 20 log to the base 10 E1 by E2. Similarly, shielding effectiveness for the magnetic field is equal to 20 log to the base 10 H1 by H2. Next is apertures in shielding walls. Apertures can be modeled as rectangular slots or circular hole. What is the aperture? It is small opening. Suppose if openings are present in the shielding walls means the external fields can penetrate through the apertures to the receptor. This is the diagram that explains the penetration of the external electric field through the shielding, then it can be reaching the receptor. One of the aperture in the barriers is holes in thin barriers. Suppose if we consider a plane wave which is incident in a normal manner on the shielding means the field depends upon the aperture size, because there are two types of incidence, normal as well as oblique incidence. We have considered the normal incidence here. Here, for the normal incidence of the plane waves, the field depend upon the aperture size. This aperture and the opening should not be larger than lambda by 50 to lambda by 20. If it is large, mean effectiveness of the shielding will not be there. Suppose the wavelength of the incident light is greater than twice the whole diameter, means this shielding effectiveness depends on the reflection loss. Shielding effectiveness formula is 20 log to the base 10 lambda by 2d. D is the diameter of the hole. If it is greater than the thickness of the shielding, means this is the equation for it. Thank you.